Hi, my name's Ty Hedrick. I'm an assistant professor of biology at the University of North Carolina at Chapel Hill. And I study flying animals like this beautiful hummingbird here. We've slowed this hummingbird down to 75 times normal speed with a high-speed video camera so that we can get a close look at what it does for its mechanics and aerodynamics as it makes this incredibly agile turn. This bird manages to flap its wings 50 times a second, and it turned 180 degrees in about 1/3 of a second. In our paper in the journal Science, we compared yaw turns, that is, just the animal spinning quickly to the left or to the right, over a wide range of animals, going from fruit flies at the tiny end of the size scale all the way up to some big cockatoos, to see if we could get some general rules for animal flight maneuverability and turning. What we found was pretty interesting, because here we see in the hummingbird, it's coasting along, and right about here, it starts really accelerating into its turn. And that means that it's suddenly pushing a lot harder on one wing than another. But as we look at what the hummingbird has to do to slow down at the end of the turn, before we did this study, we figured that meant it had to shift gears and stop flapping harder on one side and start flapping harder on the other side. Turns out that that's not the case, that instead the hummingbird can just shift back to flapping symmetrically, equal wing beats on left and right, and that'll bring it to a halt in a few more milliseconds, coasting quickly to a slow and to the proper position. So this is one of the things that makes animal flight so maneuverable and stable compared to anything that we as humans can build.